multiplying binomials is using the distributive property twice. The method we use for this, or to remember this, is FOIL, or first, outer, inner, and last. In our first example, we have the first binomial, x plus 3, and we want to multiply that by the second binomial, x plus 2. We distribute the terms from the first parentheses to each term in the second parentheses. So when we take our first terms, x times x, they're the first term in each parentheses. That gives us x times x, which is x squared. We then take our inner terms, our outer terms, or O, this is the outer term in each parenthesis, the 3 and the 2. The x and the 2, the bookend terms, the x and the 2. X times 2 gives us 2x. We then take the inner terms, these are the two terms closest to each other but not in the same parentheses. 3 times x, which gives us 3x. And lastly, we take the last terms. This is the last term in each parenthesis, the 3 and the 2. And 3 times 2 is 6. So we have x squared plus 2x plus 3x plus 6. We then combine like terms to get x squared plus 5x plus 6, which is our solution. In our second example, we have x minus 6, and we want to multiply that by the binomial x minus 3. Again, we are going to distribute the terms from the first parenthesis to each term in the second parenthesis. So when we do our first terms, again, first is the first term in each parenthesis. So x times x, these are our first terms. X times x gives us x squared. Then we want to do our outer terms. These are our bookend terms. X times negative 3. We need to be very careful when we have sign changes. There's still a plus sign between these because there's always going to be an addition between each step in the FOIL. X times negative 3 will result in a negative 3x. So we can do plus a negative 3x, or you could do minus 3x, whichever is your choice. We then do our inner terms. These are the two that are closest together. In this case, it will be negative 6 times x. Again, I have a plus sign between, but because I'm multiplying by a negative, I get a negative 6x. Lastly, I do my last terms, negative 6 times negative 3, negative 6 times negative 3. Because when multiplying a negative by a negative, I get a positive 18. I'm again going to combine my like terms to come up with my solution. Negative 3x plus negative 6x, because we're adding a negative to a negative, it gets more negative. I will have negative 9x. So I'll end up with x squared plus negative 9x plus 18. If at any point you need to pause or rewind the video, please make sure you do that so you can get all these notes copied. Our third example is a little bit different. We're going to multiply the binomial x minus 5 times x plus 5, and you'll see why it's a little bit different here at the end. Our first terms, again, x times x. Which results in x squared. Our outer terms, x times positive 5, which will give us a 5x. our inner terms, negative 5 times x, which will result in a negative 5x. And then our last terms, negative 5 and positive 5, result in a negative 25. Still combining like terms, but now when I add a 5x to a negative 5x, they cancel each other out. So I'm left with x squared minus 25. Both x squared and 25 are called perfect squares. This is what we call a difference of squares. The reason it's called a difference of squares is because each of these is a perfect square and there's a subtraction or a difference between them. This will be very important when we come back to factoring. Our fourth example looks completely different than our first three. We have x plus 3, and we're squaring that quantity. What does it mean to have a quantity squared? Correct. It means to multiply it by itself. So first I'm going to rewrite this as x plus 3 times x plus 3. Then I multiply my first terms, and I get x times x, which is x squared. I multiply my outer terms, x times 3, which is 3x. My inner terms, which is also 3 times x. Sorry, gotta change my parentheses here. 3 times x, which gives us 3x. And then my last terms, 3 times 3, which will result in 9. When I combine my like terms, I get x squared plus 6x plus 9. This is what we call a perfect square trinomial. This again will become extremely important when we talk about factoring. Our last problem, we have a note. It says pay close attention to the signs in this problem. We don't just have a change in sign between our problems. We also have a negative sign in front of the 4x, so we need to be very careful with that. This one is our final example to show you that you can do these problems even if there's multiple letters. So we're going to take our first terms, 2x times 4x, or times negative 4x. That will result in a negative 8x squared. Again, x times x is x squared. We do our outer terms. We have 2x times negative 5y. 2 times negative 5 is going to give us a negative 10. Negative 10xy. When we have multiple variables, remember we list them alphabetically and by order of power. So then we have negative 3y times negative 4x for our inner terms. If you'll notice, I still put a plus sign in between each of these. Even though I'm multiplying by negatives, there's still a plus sign between the FOIL. So negative 3 times negative 4 will give me a positive 12. And again, this is going to be an xy. All right? Just because I multiplied y before x doesn't change it to a yx. All right, we still list them alphabetically and by order of power. So then lastly, negative 3y times negative 5y. Negative 3 times negative 5 will again give me a positive number. It'll be positive 15y squared. I combine my like terms. I'll have negative 8x squared plus 2xy plus 15y squared. If you have any questions about this, please make sure to ask either myself or Miss Miller during class today while we're working on our activity. Thank you.